The cosmos is a theatre of unimaginable scale, a sprawling stage where stars dance in orbits that span light years, and our tiny blue planet is but a fleeting speck in the grand narrative. The solar system, our cosmic neighbourhood, feels like a tranquil haven, a place where planets spin in predictable harmony, and the sun's warm embrace keeps everything in check. But don't be fooled by this illusion of calm. The universe is a chaotic, restless beast, and every so often it throws a curveball that shakes the very foundations of our understanding. Imagine this: a rogue star, a blazing fireball from the depths of the Milky Way, tearing through the void and passing closer to Earth than humanity's farthest spacecraft, Voyager 1. Yes, closer than the probe that's been soaring through the interstellar abyss for decades, carrying our hopes and dreams into the unknown. This isn't science fiction. It's a jaw-dropping possibility backed by cutting-edge research that's rewriting the story of our solar system. Buckle up, because this tale is packed with shocking revelations, emotional twists, and mysteries that will leave you staring at the stars in awe. Picture the Milky Way, our galaxy, a swirling spiral of 200 to 400 billion stars, each one a fiery titan with its own gravitational pull, its own destiny. These stars aren't static. They're hurtling through space at breakneck speeds, sometimes as fast as 20 kilometers per second relative to our Sun. The galaxy is vast, stretching 100,000 light-years across, but it's not an empty void. It's a crowded cosmic ocean, and in this ocean, stars occasionally brush past one another like ships in the night. Most of these encounters happen at safe distances, hundreds of thousands of astronomical units away, where one astronomical unit is the distance from Earth to the Sun, about 93 million miles. But every few 100,000 years, a star gets bold, venturing so close that it could rattle the delicate balance of our solar system. Calculations suggest the closest stellar flybys happen within 500 astronomical units, roughly 10 times the distance from the Sun to Pluto. Even rarer are encounters within 1,500 astronomical units, occurring once every billion years or so. These are cosmic near misses, events so rare they're almost unthinkable, yet they've happened, and one may have come closer than we ever dared imagine. Now let's set the stage for the heart-pounding revelation. Voyager 1, launched in 1977, is humanity's farthest emissary, drifting 164 astronomical units from the Sun as of today, May 9th, 2025. It's a lonely pioneer, beaming back faint signals from the edge of interstellar space. But what if billions of years ago, a star, a real blazing star, swooped in even closer than that? Recent studies have sent shockwaves through the astronomical community, proposing that a stellar flyby came within a staggering 110 astronomical units of the Sun. That's closer than Voyager 1, closer than the New Horizons spacecraft, which is currently 60 astronomical units away, probing the Kuiper Belt's frozen depths. To put this in perspective, Proxima Centauri, the nearest star to us today, is over 268,000 astronomical units away, 4 light-years. This rogue star wasn't just passing by, it was practically knocking on our cosmic door. This wasn't a massive supernova or a dazzling giant. The intruder was likely a red dwarf, a star about 0.8 times the mass of our Sun, small but dense, with enough gravitational muscle to cause chaos. Red dwarfs make up roughly 75% of the Milky Way's stars, So it's no surprise one of these stealthy wanderers might have been the culprit. The evidence for this flyby isn't just speculation. It's rooted in the strange, rebellious orbits of objects in the solar system's farthest reaches. Beyond Neptune, in the shadowy realm of the Kuiper Belt and the scattered disk, astronomers have found trans-Neptunian objects, TNOS, that defy the rules. Some, like the dwarf planet Sedna, swing out to 937 astronomical units on wildly elliptical paths. Others have retrograde orbits, moving backward compared to the planets, as if they've been flung into disarray by an unseen force. Then, there are the irregular moons of Jupiter, Saturn, and Neptune, moons like Saturn's Phoebe, which orbits in the opposite direction of its planet, hinting at a violent past. These cosmic oddities are like fingerprints at a crime scene, and scientists believe the culprit was a star that came too close. To unravel this mystery, researchers turned to supercomputers, running over 3,000 simulations to test whether a stellar flyby could explain these anomalies. The results were mind-blowing. The simulations showed that a star passing within 110 astronomical units, less than 4 times the distance from the Sun to Neptune, could have warped the orbits of TNOs, sending some into retrograde paths and others, like Sedna, into distant, eccentric loops. It could also explain the irregular moons, which may have been TNOs snatched from the outer solar system by the gravitational tug-of-war between the passing star and the giant planets. Imagine the scene, a red dwarf blazing through the outer solar system, its gravity stretching and twisting the orbits of icy bodies like a cosmic puppeteer. The Kuiper Belt, a ring of frozen debris beyond Neptune, would have been thrown into turmoil. Even the Oort cloud, a distant shell of comets encircling the solar system, could have been stirred, sending icy missiles hurtling toward the inner planets millions of years later. This stellar flyby wasn't a one-time event with no consequences. Its ripples are still felt today, etched into the architecture of our solar system. The irregular moons of the outer planets are relics of that chaotic encounter, captured during the star's brief but disruptive visit. The strange orbits of TNOs like Sedna are like scars, evidence of a gravitational battle fought billions of years ago, and the Oort cloud, that vast reservoir of comets, may still be sending reminders of the flyby in the form of long-period comets that blaze through the sky every few centuries. The emotional weight of this discovery hits hard. Our solar system, this seemingly stable home, was once invaded by a stranger from the stars, a visitor that left its mark and then vanished into the galactic night. It's a reminder of how fragile our place in the cosmos is, how even the stars can reach out and touch us across unimaginable distances. But the story doesn't end there. The solar system's outer reaches are still yielding secrets, and humanity's spacecraft are on the front lines. New Horizons, launched in 2006, has been a trailblazer, speeding through space at over 36,000 miles per hour. In 2015, it gave us our first close-up look at Pluto, revealing a world of ice mountains, nitrogen plains, and flowing glaciers that looked like something out of a dream. But Pluto was just the beginning. New Horizons pressed on into the Kuiper Belt, a frozen graveyard of the solar system's birth, stretching 2 billion miles wide. In 2019, it flew past Arakoth, a reddish, snowman-shaped object that offered a glimpse into the building blocks of planets. Today, at 60 astronomical units, New Horizons is still sending back data, its signals taking over 6 hours to reach Earth. And what it's found is nothing short of astonishing. Astronomers using the Subaru telescope in Japan have been scouring the Kuiper belt, discovering 263 new objects. But 11 of these objects are game changers. They're not in the Kuiper belt. They're beyond it, in a region over 70 astronomical units from the Sun, where nothing was supposed to exist. These distant objects hint at a hidden structure, a second ring of debris that challenges everything we thought we knew about the solar system's edge. Between this new structure and the Kuiper belt lies a mysterious gap, a region eerily empty of objects. This isn't a fluke. Gaps like this are common in other planetary systems, suggesting our solar system isn't as unique as we thought. The discovery is electrifying, a clue that the solar system's boundaries are far more dynamic and complex than any textbook could have predicted. The emotional stakes of this revelation are profound. For centuries, humanity has looked to the stars, dreaming of distant worlds and alien life. Yet right here, in our own backyard, mysteries abound. The solar system isn't a static museum. It's a living, breathing entity shaped by cataclysmic events like stellar flybys and still hiding secrets in its darkest corners. Consider Europa, Jupiter's icy moon, with its subsurface ocean that could harbor life. Or Enceladus, Saturn's geyser-spewing moon, where plumes of water hint at a hidden sea. Even Venus, a hellish world, has shown traces of phosphine in its clouds, a possible sign of microbial life. Mars, with its ancient riverbeds and subsurface ice, whispers of a wetter, warmer past. These discoveries remind us that life might be closer than we think, lurking just beyond our reach. And then there's the tantalizing possibility of Planet 9, a hypothetical giant lurking in the solar system's outer reaches. Since 2015, researchers have been chasing evidence of this elusive world, driven by the strange orbits of distant TNOs. Recent studies have bolstered the case, showing that a massive object, perhaps 5 to 10 times Earth's mass, could be sculpting the paths of these objects, pushing them into Neptune-crossing orbits. The Vera Rubin Observatory, set to begin operations soon, could finally confirm or debunk Planet 9's existence. If it's real, it would redefine the solar system, proving that even after centuries of exploration, we're still strangers in our own home. The stellar flyby, the hidden Kuiper belt structure, Planet 9, these aren't just scientific curiosities, they're a wake-up call, a reminder that the universe is vast, unpredictable, and full of surprises. The star that came closer than Voyager 1 didn't just pass by, it reshaped our solar system, leaving clues that we're only now beginning to understand. It's a humbling thought. While we send probes to the stars once came to us, whispering secrets we're still struggling to hear. This is a story of cosmic connections, of a universe that's alive with motion and mystery. It's a call to keep exploring, to keep questioning, because every new discovery brings us closer to understanding our place in the grand tapestry of the cosmos. What's out there, waiting to be found? The answer lies in the stars, and it's more breathtaking than we could ever imagine. The narrative doesn't stop with the flyby or the Kuiper belt secrets. The solar system is a puzzle, and each new piece we uncover reveals a picture more intricate and awe-inspiring than the last. Let's dive deeper into the mechanics of that stellar encounter. When a star passes within 110 astronomical units, it's not just a close call, it's a gravitational earthquake. The Sun's gravity holds the planets and Kuiper belt objects in a delicate dance, but a visiting star introduces chaos. Its gravitational pull tugs at the outer solar system, stretching orbits, flipping directions, and scattering debris like confetti. The simulations that confirmed this flyby didn't just model the star's path, they recreated the aftermath, showing how TNOs like Sedna could have been slung into their bizarre orbits. Sedna, for instance, takes 11,400 years to complete one loop around the Sun, swinging from 76 to 937 astronomical units. That's not normal behavior. It's the kind of orbit you get when something massive like a star gives the solar system a hard shove. The irregular moons add another layer to the story. Take Phoebe, Saturn's backward orbiting moon. It's small, dark, and orbits far from its planet, unlike Saturn's regular moons, which formed alongside the planet and follow orderly paths. Phoebe's retrograde orbit suggests it was once a free-floating TNO, perhaps from the Kuiper belt, until the stellar flyby disrupted its path. The giant planets, with their massive gravity, could have snatched these displaced objects, turning them into moons. Jupiter and Neptune have similar irregular moons, each one a testament to the star's influence. It's like finding a stranger's luggage in your house. Those moons don't belong, and their presence points to a cosmic break-in billions of years ago. The Oort cloud, that distant comet nursery, is another victim of the flyby. Stretching up to 100,000 astronomical units from the Sun, it's a fragile shell of icy bodies, easily disturbed by passing stars. A close encounter at 110 astronomical units would have sent shockwaves through the Oort cloud, nudging comets out of their orbits. Some of those comets could still be on their way, taking millions of years to reach the inner solar system. When we see a brilliant comet blazing across the night sky, we might be witnessing the long-delayed echo of that stellar flyby, a reminder that the universe's actions have consequences that span eons. It's a thought that stirs the soul. Every comet, every meteor shower could be a message from a star that visited us before humanity even existed. Now let's zoom out to the Kuiper belt and the new structure beyond it. The Kuiper belt has always been a treasure trove for astronomers, a region where time stands still. Its objects, preserved in a deep freeze since the solar system's formation 4.6 billion years ago, are like fossils, holding clues to the Sun's birth. But the discovery of 11 objects beyond 70 astronomical units is a game-changer. These aren't stray rocks. They're part of a dense, organized ring, separated from the Kuiper belt by a gap where almost nothing exists. This gap isn't a mistake. It's a feature seen in other planetary systems, where planets or gravitational forces clear out debris. In our solar system, it could be a sign that Planet 9 or even the stellar flyby sculpted the outer regions, creating a complex architecture we're only now beginning to map. The emotional resonance of this discovery is hard to overstate. For so long, we've thought of the solar system as a simple place: a sun, 8 planets, and a scattering of moons and asteroids. But it's so much more. It's a battleground, a canvas painted with the scars of cosmic encounters. The star that came closer than Voyager 1 didn't just pass through. It left a legacy, a story written in the orbits of distant objects and the moons of giant planets. It's a story that connects us to the universe, reminding us that we're part of something vast and ever-changing. Every time we look at the night sky, we're seeing the echoes of that encounter, the fingerprints of a star that dared to come close. The search for answers continues, and humanity's tools are sharper than ever. New Horizons is still out there, pushing the boundaries of what's possible. The Subaru telescope, with its world-class optics, is scanning the heavens for more clues. And soon, the Vera Rubin Observatory will join the hunt, its massive camera capable of mapping the entire sky in unprecedented detail. These instruments are our eyes, our hands, reaching out to touch the universe. They're extensions of our curiosity, our drive to know more, to uncover the truths hidden in the dark. But the real power of this story lies in its ability to move us. It's not just about stars and orbits, it's about our place in the cosmos, our longing to understand the forces that shaped our world. The stellar flyby is a reminder that the universe is alive, that it's been shaping and reshaping our solar system for billions of years. It's a call to wonder, to imagine, to dream. What else is out there? What other visitors have come and gone, leaving their marks on our cosmic home? The answers are waiting, and they're closer than we think. The stars aren't just distant lights, they're storytellers, and their tales are written in the sky. All we have to do is listen. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.